Walk into any corporate boardroom today, and you'll hear executives throwing around terms like AI, machine learning, and GenAI, as if they mean the same thing. It is like watching a realm ruled by NPCs with no idea which great house sits on the throne. In 2025, treating these highly distinct technologies as interchangeable buzzwords indicates a critical failure in strategy. You are essentially marching into a digital winter armed with a butter knife. This diagram illustrates how these systems actually relate to one another. Like a set of Russian nesting dolls, it maps the lineage from the broadest category of computer science down to the specific creative technologies at the center. We will trace this bloodline, step by step, seeing how machines evolved from basic, hard-coded rules to absolute main character energy. Mastering this taxonomy serves a practical purpose. Identifying the exact capabilities of each tier allows a business to deploy the right tool for the right data challenge. The outermost layer of our nesting doll is artificial intelligence, a term coined in 1956. It represents the broad concept of creating machines capable of mimicking human cognitive functions. Early AI systems functioned like a city guard. They were strictly rule-based, meaning they could only execute the specific logical commands that human programmers manually wrote into their memory. Inside that outer shell sits the first tier, machine learning. Instead of requiring a human to write every single rule, a machine learning system uses algorithms to identify patterns and data entirely on its own. This decision tree shows the model analyzing historical records to calculate the mathematical odds of a future outcome. By spotting recurring patterns, it powers predictive tools, flagging fraudulent credit card charges, filtering spam, and driving retail recommendation algorithms. By teaching computers to learn from experience, machine learning shifted computing from following instructions to making data-driven predictions. This gave enterprises their first real tactical foresight. This animation shows a neural network, a computing architecture inspired by the biological structure of the human brain. This multi-layered approach brings us to our next nested layer, deep learning. To function, these models require the massive physical infrastructure seen here. Deep learning is extremely data-hungry, requiring specialized GPU compute power to process information through thousands of simultaneous calculations. This scale gives deep learning the ability to process unstructured data. Unstructured data is information that doesn't fit into a standard spreadsheet, such as raw text, complex audio files, and video streams. When a model can parse unstructured information, it can perceive the physical world. This is the technology reading medical scans to detect tumors and allowing an autonomous vehicle to navigate visually. Finally, we reach the innermost layer, generative AI. It applies these deep learning architectures to the task of synthesizing new information rather than simply processing it. Generative AI uses architectures like the transformer, a model structure that excels at understanding context, to create net new content. Instead of just identifying patterns, it is synthesizing original outputs like text, images, or code from scratch. Tools like ChatGPT, Midjourney, and Sora are the digital dragons of the modern age. They absorb vast amounts of existing data to produce unique assets that have never existed before. These systems transition into autonomous production, where the model outputs unique assets rather than identifying existing ones. These different tiers of technology are not fighting each other for dominance. They operate best as an integrated small council, where each layer handles a specific stage of the workflow. At step 1, AI handles rule-based routing. Step 2, machine learning analyzes historical trends to predict market shifts. At step 3, deep learning analyzes unstructured satellite imagery to verify predictions. Finally, GenAI uses this context to draft customized board reports. You must stop using these terms interchangeably. Memorize this lineage to ensure you are matching the right tool to the right problem and avoiding a corporate red wedding. Mastering this taxonomy ensures every technological investment is matched to the specific data challenge at hand, providing the clarity needed to claim the iron server.